All right, so we have particles x and y. They're moving along the x-axis. Same equations we just had, right? Okay, so it says at t equals 1, is particle y moving to the right or to the left? Now, what gives us direct? How do we decide if it's moving to the right or left? What part of this stuff tells us that? Is it position, velocity? So we have, this is PVA, is kind of how we abbreviate this. It's position, velocity, acceleration. So it's going to be one of those three things. The position is just where it is. Velocity, remember, velocity and speed are not the exact same thing. Speed just gives you literal speed, but velocity also gives you direction. So if we're talking about a direction like right or left, we need to figure out what the velocity function is. And we're talking about particle y, so I have to take the derivative of this position to get my velocity. So I want velocity sub y of t. Okay? And I'm going to take the derivative here. And when I take the derivative, what process am I going to have to use here for my derivatives? Chain rule, okay? Because I'm not just taking the cosine of t, I'm taking the cosine of a function. So I take the derivative of the trig. What's the derivative of cosine? Negative sine. So I have negative sine. I leave the inside alone. Pi times t squared over 4. Then I multiply all of that times the derivative of the inside. What's the derivative of that going to be? Two pi t over 4, right? So you could write it like this if you wanted to. So just think about this. This is the same thing as 1/4 times pi times t squared, right? Isn't that the same thing that's inside there? So when I multiply, it's going to give me, I can get 1/2. Now, if I just did it from there, that would give me 2 pi t over 4. That's the same thing as when I do this, and then it's just going to end up over 2. You can do it either way, but that 4 just hangs out there. So this is going to end up, and if I do it here, I get 1/2 pi times t. But either way, if I want to put it all back in 1, I can just do pi times t over 2. You with me on that for the derivative? Okay. You write it however you want, but that's what's happening there. Okay. So, and I want to know at t equals 1, is it moving right or left? So that means I need to find the velocity for my y particle at 1. Bless you. Bless you. So this is negative sine of, well, t squared is just 1, so that's pi fourths, right? Times pi times 1 is pi halves. Now, this is, if all I was doing was getting the answer for what is the velocity at 1, that is a safe stop. But I need to know what the sign is for not the SIN, the SIGN, what the sign of this answer is. Well, what is the SIN, S-I-N-E, of pi fourths? Square root of 2 over 2. Square root of 2 over 2. Pi fourths. Square root of 2 over 2. So this is negative square root of 2 over 2 times pi halves. Whether I clean that up or not, do I know what the SIGN of this is going to be? Yes. Okay, so which direction are we moving? Left. So I can say at t equals 1, particle y is moving left because v sub y of 1 is negative. I could say is less than 0. I could say the velocity at 1. I could say a whole lot of things there. Okay. What questions you got? We all good so far? Okay. So now this says at t equals 1, the velocity of particle x is the velocity of particle x increasing or decreasing. Okay, so what do I look at to know if the velocity is increasing or decreasing? What has to be true? What has to be true for it to be increasing? velocity and acceleration have the same sign, the velocity is increasing. Opposite signs, then it is decreasing. So that means I need to look at the velocity and the acceleration, and this is particle x. So I have the position right here. I need to find the velocity and the acceleration. So the velocity for particle x, v of t, equals, take the derivative, 3t squared minus 12t plus 9. Then I also need to do the acceleration, right? Acceleration for x of t. Do you understand why I have to use these little subscripts? Because we have an x and a y, we're finding the velocity and acceleration. Good. So then, how do I find the acceleration? Derivative of what? Velocity, yeah. So this is going to be 6t minus 12. Everybody good with that? All right, so then I'm going to find v sub x of 1 would be 3 times 1 squared minus 12 times 1 plus 9. Let's see, that's going to give me what? 3 minus 12 plus 9, is that 0? Yes. Okay. All right, and then a sub x of 1 is equal to 6 times 1 minus 12, negative 6. Y'all agree with that? Okay. So, what do you think here? What does it mean when your velocity is 0? No direction, no speed, you're at rest, right? And then a sub 1 of the acceleration is at negative 6. So when we get to that 0, if I'm at 0 and the signs technically here, I mean 0 isn't positive or negative, right? But are the signs the same or are they different? They're different, okay? So this means that at t equals 1, the velocity of particle x is what? Decreasing? Because signs for a sub x of t and b sub x of t are different. Okay, we good with that? All right. Well, now we want to find the displacement of particle y. What is the displacement? It's position, right? Displacement is just position. So if I was to walk all the way to that wall and come right back here, what's my displacement? 0, okay? Now I walked far, right? But my displacement is 0. So basically we're just looking for position. What is my position? If it took me 5 seconds to walk there and 5 seconds to walk back, at 10 seconds, my displacement is 0, right? Because my position, I'm back here at 0. You with me on that? So when it asks for displacement, all we are looking for here, this is just position. Okay. The particle y after the first 5 seconds. So how are we going to find that? Just plug it in. It's just y of 5, right? And I can't see that up there. So. What? Because the x and our original x and y, those are our position functions, right? And so we are substituting this in because it says y. So this is going to be the cosine of pi times 5 squared over 4. So that's equal to the cosine of what? 25 pi over 4. Now, can we actually find what that is? Sure we can. Do you know your pi fourth stuff? All right. So your pi fourth stuff, how many, so if I went around the circle, 2 pi, how many fourths is that? 8 pi fourths, right? So I can go around 8, 16, 24, right? And then 1 more pi fourths gives me 25. So it's really just pi fourths. I'm in that first quadrant. You see how we went around like that? So what is the cosine of 25 pi fourths? Yeah, just the square root of 2 over 2. So is my displacement square root of 2 over 2? The answer is yes, if I started at 0. Right? Think about this. If my initial position was somewhere else, and then I moved, I'm going to have to subtract, right? So what else do I need? I need my initial position, right? How do I find my initial position? Did we already find it somewhere? We didn't find it anywhere yet. So we'll have to find it. Y of 0. What's y of 0? Oh, we found it on the other one, right? It's 1, okay? 1. You agree with that? Okay. So what do I need to do with those two things? I'm actually going to subtract them. Take my final position minus my, so it's final minus initial. Final position minus initial position. So it's the square root of 2 over 2 minus 1. That's the displacement. It has to do with position. Final minus initial. How far you are from where you started. So if I went back to my start, if I started at 0, then 0 minus 0 is 0. Otherwise, you got to subtract. We good? Okay. Questions? All right. Oh, yeah. We don't have to go any further. Yeah, absolutely. I wouldn't go any further for sure. All right, so now is particle X moving away or towards the origin at 2 seconds? So what do we need to know to figure that out? I need to know velocity, and what else? I also need to know position. So when you were looking at away or towards, I need not only direction, but I need location. So we're going to need position, and we're going to need velocity. Make sense? Okay, so I need position for particle X. X of 2 equals, did we already find that somewhere? Because sometimes we've already found stuff. Nope. Okay. So that is equal to, and I can't see my equations, so that is 2, is that 2 cubed? Mine looks like a blob. Minus 6 times 2 squared plus 9 times 2 plus 11. So it looks like 8 minus 24 plus 18 plus 11. Yes, negative 16, 13. I agree with 13. Y'all agree with 13? Yes, okay. What else do I need? I need velocity for particle X. That's 2. Do I have the velocity function already? We did find that, right? Okay. So that means that I want, did we do that one? No, just velocity in general. Oh, it's right there. Okay, sorry. Making sure that we had actually done it and I wasn't making things up over here. Then this is going to be 3 times 2 squared minus 12 times 2 plus 9. Should give me negative 3. Okay. So let's think about what this tells us. Here I am, here's my x-axis, right? Let's say here we are at 0. My position, I'm here at 13. Here's where my little particle guy is. Which way is he moving? Left or right? Left. So is he moving towards or away from the towards? Okay. So then I can say at t equals 2 seconds, particle x is moving toward the origin because x of 2 is positive or greater than 0, and b sub x of 2 is less than 0. And you can write positive or negative, whatever, but that's what it boils down to. And even it just being positive or negative, I suggest you make yourself a little line like that and figure it out. There you go. It's the teal one. All right. So now I want to know about slowing down. How do I figure that out? Sign chart. Okay. Slowing down. What do we have to know in order to, what are we looking at if it's slowing down? What has to be, what are we looking at? Velocity and acceleration. Velocity and acceleration. All right, so velocity and acceleration. So my b sub x of t, what is that one? That is 3t squared minus 12t plus 9. And then a sub x of t, did we already find that up there too? Yeah. 6 equals 6t minus 12. Okay. And we're going to have to look at both of these. And we're actually going to put both of these on the same sign chart. Okay. It's all good. It's better if they're all on the same sign chart, I promise. So we're going to factor this one. I think we did that on those other notes. 3 and then t squared minus 4 t plus 3. And that is t minus 1, and thank you, t minus 3. And then here, this is going to be 6 times t minus 2. So on this chart, we're putting all three things. Okay? We're putting the 1, the 3, and the 2. So 1, 2, 3. And then we're going to look at velocity and acceleration. So we'll put velocity up here, and we're going to put acceleration down here. And instead of, like on that other one where I was writing out negative, and then I made it positive and circled it, the negative part, we're not going to be writing that down anymore. I think we've got this down enough where we don't necessarily need to. Plus, that's just extra signs on here. We want to be able to get more than one thing on a sign chart. Okay? So I'm going to pick a number between negative infinity and 1. And I'm going to put it into this velocity. Okay? So I can choose 0. So if I put 0 in here, that's going to be negative times negative, which makes my velocity positive. Between 1 and 2, I can substitute in like 1.5. 1.5 minus 1 is positive. Put it in here and it's negative. When I multiply them together, I get negative. Between 2 and 3, I can do 2.5. 2.5 minus 1 is positive. 2.5 minus 3 is negative. So it's negative right there. Something bigger than 3, like 4, that'll be positive times positive, positive overall. Okay. Any questions about how I got those? Okay. If you need to you shouldn't have a ton of them where you can't remember what they were, but if you need to jot down your little negatives and positives so you don't get them mixed up, that's fine. But you don't want too much extra stuff on here anymore. Okay, so my acceleration, I'm substituting it into here. So I can use 0 again. I substitute, now this 6 and this 3, both of them, since they're positive, they don't affect the sign. So I'm just kind of ignoring them. So I substituted in here, and that's going to be negative. I substitute in 1.5, and I get negative. 2.5, and it's positive. 4, and it's positive. Okay? Everybody with me? Now it's asking me, when is it slowing down? So slowing down is when velocity and acceleration what? Have what kind of signs? Same or different? Different. Okay, so the signs are different here, and they're different here. Okay. Make sense? So then I can say that particle x is slowing down on, let's see, from negative infinity to 1 and 2 to 3 because v sub x of t and a sub x of t have different signs. Okay. Or you can say that they're opposite. Either way, that's the way I write it on there. Okay, what questions you got? All right, you understand how to use that sign chart when you have put two things on there? And so you know how we were able to start looking at them last year and go, oh, I know if it just alternates, if it does this or it doesn't. I'd be careful here because when you're mixing the equations, you can get yourself backwards. I would just go ahead and check each little thing and get it figured out. Any questions at this point? We're all good? Okay. All right, so now I want to know, are particle x and y moving towards or away from each other at t equals 2? So again, towards or away, we need position and we need velocity, okay? So let's think, I need it for x and y. So the position, so x of t, or x of 2 really. Did we find x of 2 already somewhere? Look at all your stuff. Pretty sure we do. What is it? 13, okay, good. So we can just write down what it is. We don't have to go solve it again, right? Then I need the velocity of x at 2. I think we've already found that as well, right? What's that? Negative 3, okay. Then did we find y of 2? I guess not, okay. But we can, right? No biggie. Are we sure we didn't? I'm pretty sure we didn't. Okay, even if we did, it won't kill us to do it again. So y of 2 is equal to the cosine of pi times 2 squared over 4. So that's really just cosine of pi, right? What's the cosine of pi? Negative 1. And then the velocity of y at 2. Did we find that? Nope. But we can. We found it at 1, right? So we have the velocity function, because that was one of the first things that we did. And so v sub y of 2, that's going to be negative sine of pi times 2 squared over 4 times 4 pi over 4. Y'all agree with that? Just using that from number 1 up there. All right, so again, this is just negative sine of pi. What's the sine of pi? 0. So then, I mean, that multiply is just going to give me 0, right? Just 0. What questions you got? Because I square the 2. Okay. So now let's make ourselves that little line here. So my x particle is at 13. This is where x is. And which way is x moving? Left or right? And how do we know? The velocity is negative, so x is moving to the left. Okay. My y particle is at negative 1. Which way is he moving? Is he moving? He's not moving at all. So are they moving towards each other or away from each other at that time? Are they going to get closer together or farther apart? Towards each other, okay? Which is a weird way to say it since one of them isn't moving, but it's still. All right, so then we can say at t equals 2, particles x and y are moving toward each other And then we're just going to kind of state what we had there. Because, well, we found out that x of 2 is positive. That's all we really cared about, right? Or, I mean, we cared about the location there. And the velocity of x at 2 equals 0. And y of 2 is less than 0. And v sub y of 2 equals 0. You're just restating everything you just found. It's negative 3. It's not equal to 0. Dang it. I was actually doing well once I got the right notes up here. It is less than 0. That should be less than 0. Less than 0. Thank you. Looked at the wrong one. We good? Wordy words. But not knowing what to say, I mean, you're just restating what happened there. We got a lot of proof there. We good? Okay, the average acceleration. So acceleration is the derivative of velocity, right? So if I want the average acceleration, I am finding the rate of change of velocity, yes? Rate of change of velocity. So rate of change of velocity. And I want the average rate of average acceleration. That means I want the average rate of change of the velocity. So that means the average acceleration is going to be, I have to do the slope formula with velocity. V of 5. Which one are we doing? X or Y? It doesn't say. We're going to do particle x. Particle x. Okay. So V sub x of 5 minus V sub x of 0 over 5 minus 0. Did we find the velocity at 5? We found something at 5. Oh, dang it. Okay. All right, so that means we got to find that. So velocity for x, oh, at least it isn't the trig one, right? Where's that formula? Okay. So velocity for x at 5 is going to be 3 times 5 squared minus 12 times 5 plus 9. Right. So 5 squared is 25 times 3, that's 75 minus 60 plus 9. What is that, 15 plus 9? 24? You all agree with that? Okay. What is V sub x of 0? That one's pretty easy. Wouldn't all these just zero out? It's just going to be 9, right? Okay. So this is going to give me 24 minus 9 over 5. You get 13 over 5. Oh, it's 15. Can't subtract. Good Lord. Make one mistake and then it's all downhill from there. Okay. Which is another good reason to do a safe stop. I could have stopped right there. Would have been much safer for me so I don't make a stupid mistake like that. Okay, so the acceleration for x, so the average acceleration for x is equal to 3. That notation there's not that important here. You don't have to have a lot of explanations. All right, we good? We're going to work on this more tomorrow. I gave you the assignment already, right? That you could at least start looking at. We didn't get to the calculator problem today. We'll get there tomorrow. Did we do anything on the other side? Yes, because we're going to do the calculator one, yeah. Just put an X on the other side so you know which is crappy.